Welcome to the JDK institution. In this video, I am going to discuss key insights of first year PU midterm examination. Without any delay, let's get started. Number of significant figures in 1.22 into 10 to the power 4. In this equation, we will neglect this 10 to the power 4 and remaining non-zero numbers are 1, 2, 3. So option is 3. Next one is physical quantity represented by direction m0 l1 t minus 2. It is acceleration because meter per second square. Next one is a vehicle moving with initial velocity v naught, its stopping distance is d, is directly proportional to. So let us consider a kinematic equation. V square is equal to u square plus 2as. In this equation, they have considered initial as v naught square. Therefore, v square is equal to v naught square plus 2 into. It is a stopping potential, so it is deaccelerating. I will consider as minus a, and distance is considered as d. So I will say finally, so that in this the final velocity is 0. So remaining this negative terms should be sent to this side. It will become positive. Therefore, 2ad is equal to v naught square. What I need is stopping distance. Therefore, d is equal to v naught square by 2a. So the d is directly proportional to v naught. So option is D. Next one is motion falling in a body is an example of. Motion falling in a body is an example of one dimension, because let us consider it is a rooftop. A ball falls from the rooftop in the direction like this. So it always go through in a single way or single direction. Hence it is a one dimensional motion. Next one is two scalar quantities of the following. Here force is a scalar quantity, sorry, vector, because force has both magnitude and direction. Next one is angular momentum. Angular momentum is also in vector. Work. Work is a dot product of two vectors, and hence work is an scalar. Work is an scalar. And the next one is power. Power is also an scalar because power has only magnitude, no direction. Torque is also kind of force, and hence it is also vector. And impulse, it is nothing but ft, that is force into time. So vector into scalar is a vector, and hence answer is C. Angle between two equal vectors is, angle between two equal vector is always 0. Unit of impulse is same as of, not an energy, not an velocity, not an power. It's a linear momentum. When a man jumps from a boat as a shore, the boat slightly moves away from the seashore. The total momentum of the boat and the man remains conserved. So both 1 and 2 are true, and 2 is the correct explanation of 1. Because when man jumps, how much momentum he gains, that much of momentum gains by the boat, which goes in a backward direction, while man jumps forward direction. A body initially at rest, it undergo one-dimensional motion with constant acceleration. The power delivered to it at time t is proportional to. Let us consider v. V is equal to u plus at. Here, it is initially at rest. Body is initially at rest, so it became 0. So v is equal to at. So we know that power is nothing but P is equal to Fv. We know the value V, that is 80. Therefore, P is equal to F into 80. But we know that F is equal to ma from Newton's second law. Therefore, P is equal to ma square t. And hence, P is directly proportional to t. That is option B. Next one is, if the velocity of a body becomes double, its kinetic energy will becomes, what happens is it becomes 4 times. That is Ke is equal to half mv square, that is equal to half m into 2v whole square, that is becomes half m 4v square. I can write it as 4 into half mv square, right? So half mv square becomes ke, that is 4. Hence, it becomes 4 times. Next one is, if the following, what is the following, which of the following does the center of mass lie outside the body? A pencil. A pencil is nothing but a cylinder. The center of mass of this lies here. A shot put is a sphere. The center of mass is concentrated towards the center. A dice, the center of mass is also concentrated at the center. Where comes to bangle, the center of mass is concentrated around the circumference of that bangle, and hence we call it as D, a bangle. Next one, physical quantities given in column 1 to describe the linear motion with their analogues in the rotational motion in a column, identify the correct one. So mass is momentum of inertia. Okay, no doubt it is a moment of inertia, that is I is equal to I is equal to mr square, where momentum is angular momentum and force nothing but torque. Therefore option is B. The kinetic energy of a body in a rotational motion is given by, it's a direct question, k is equal to half I omega square, that is option B. When the body is taken to moon from the earth, then we know that mass always constant. So mass always constant, but weight decreases because weight depends on gravity. SI unit of gravitational constant is Newton meter square per kg square. Next one is area under velocity time graph gives displacement. Here it is the 16th one. Slope gives the acceleration. The direction of centripetal acceleration is always directed towards the dash of the circular path center. It's the towards the center. In centrifugal, it is away from the center during the centrifugal. During the centripetal, it is towards the center. Centrifugal, away from the center. Next one is coefficient of kinetic friction is the ratio of kinetic friction to, we know that the equation mu k is equal to Fk divided by normal reaction, and hence it is coefficient of friction is ratio of kinetic friction to normal reaction, that is 18th one. The amount of work done by spring force in a cyclic process is 0, because we all know that spring force is a conserved force, and hence it is 0. Kepler's second law or law of area is a consequence of law of conservation of angular momentum. Now coming up to the 2 marks question, show that the maximum range of projectile if u square by g. If u square by g, we all know that r square is equal to u square sine 2 theta by g. Okay, it becomes maximum when this sine 2 theta becomes 1. When it becomes 1, when 2 theta becomes 90 degree or theta become 45 degree, then what happens is r is equal to u square by g. Understood? If you return this one, you will get 2 marks. And next one is define linear momentum and SI unit. You have to mention the linear momentum and explain the SI unit. Next one is Newton's third law of motion. You have to explain the Newton's third law and give the explanation and statement. Next one is constant force F 2I plus j cap minus k applied over a particle which displaces it from its origin to the point 3i minus 2j. Calculate the work done on the particle ijk unit vector xyz area on the axis of the system. What happens is, we all know that we need to find the calculate work done. They have given f, and they have also given displacement delta s. We know that w is equal to f into delta s. We know the value of f, that is 2i plus j minus k into 3i 3i cap minus 2j cap. It will becomes like 6 minus 2, that is this 3 2s are 6 and 1 2s are 2, and it will become 4. So 4 joule is the answer. And next one is, define angular velocity of a rigid body. Write the relation between linear velocity and angular velocity in a vector form. You have to define the angular velocity, and you have to derive the equation, that is v is equal to w into r vector. If you derive this equation, you will get the 2 marks. Write any two factors on which moment of inertia depends. You have to write any two factors like mass of the body, size of the body, or shape of the body, like that. Next one is, state and explain universal law of gravitation. You have to explain the universal law of gravitation, that is F is equal to G into m1 m2 by r square. Next one is, you have to obtain the relation between acceleration due to gravity and universal constant. You know that F is equal to G into m1 m2 by r square, and from Newton's second law, you know that F is equal to ma, and here acceleration is due to gravity, and it becomes mg. Substitute this, what happens is, mg is equal to g m1 m2 by r square. What happens, this m and let us consider this is m1 m1 cancel, remaining is g m2 by r square. Understood? Or you can write it as me m1. This is the expression. And next one is, check the correctness of the equation using dimensional analysis. You have to find the check the dimension of this. It will comes under l, sorry, l is equal to l plus l, because we know that distance x become l, and v naught is l into t minus 1, and time is t, and acceleration l t minus 2 and t square, and it becomes l plus l. Okay. Next one is, draw the position time graph. For positive, for this positive acceleration, it will like this. For negative acceleration, it will like this, and for zero acceleration, it is a constant velocity, it is like this. Okay. Now define average acceleration. Write the expression on average acceleration in terms of angular component. You have to mention what you mean by average acceleration, then you have to find the instantaneous acceleration and average acceleration component. Show that the impulse of the force is equal to the change in linear momentum produced by a body. You can find out that impulse is nothing but large force acting in a short interval of time. Therefore I can write it as, sorry, f f is equal to, sorry, I is equal to f into delta t, but f is nothing but change in momentum. Therefore I is equal to delta p by delta t, that is equal to delta t into delta t. This will cancel, then remaining is I is equal to delta p. Change in momentum is nothing but m into delta v, change in velocity. I can write it as m is equal to v minus u. This is the required equation. Okay. Next one is mention any three advantages of friction. You have to write any three advantages of friction. You will get 3 marks. Kinetic energy of an object reaching the ground. Is it gravitation? Show that gravitational potential energy. Okay. You have to find out that is v square. What you need to find out is v square. Sorry, v square is equal to v square minus u square is equal to 2as. Here initially it is 0. Therefore v square is equal to 2gh. Here acceleration a becomes g due to this one, and here I taken as distance h, it is an height. After that, what you need is the kinetic energy of an object when it is reaches the ground, that is ke is equal to of mv square. Substitute this v here, it will become of m into 2gh. Here 2 cancel, remaining is mgh. It is the required expression for this problem. Next one is you have to define the what do you mean by escape velocity and expression of escape velocity and value of escape speed of the earth. That is that is uh, 11.2 kilometer per second. I think 35th question. A torque is given. We know that torque tau is nothing but r vector. Tau vector is equal to r vector into f vector. So here f is given and r is given position. You have to do the determinant form. You will get the final expression, that is 2i cap plus 12j cap plus 10k cap. Okay. And the next one is fifth main. You have to derive the expression with the graphical representation, that is v square minus v naught square is equal to 2x. It is nothing but v square is equal to u square plus 2as. That expression only they have substituted x in the form of s and v naught in the form of u square. Next, you have to define the centripetal acceleration and obtain the expression of centripetal acceleration of particle executing the circular motion. You have to explain this derivation. Deriving this, you will get 5 marks along with the diagram. Next, derive the expression for maximum speed on the car backing off road in a circular motion. The final equation is Vmax is equal to square root Vmax. Here, the final expression is Vmax is equal to square root of tan beta plus mu s divided by 1 minus mu s tan theta and rg. If you derive this equation, you will get the 5 marks. Okay. Next one is derive the expression for potential energy in electric stretching. You have to derive the u is equal to half kx square derivation. Next one is define angular momentum, mention SI unit. SI unit is kg meter square per second. Kg meter square per second. Show that the torque is equal to the rate of change of angular momentum of the particle. You have to derive the formula, that is L is equal to R vector cross P vector, and deriving this you will get that dl by dt is equal to tau. This expression you have to derive for this equation. Okay. Next one, coming up to the numericals. A cricket ball is thrown at a speed of 28 meter per second. So we consider this as a initial velocity, that is u. in the direction above 30 degree. So they have given theta, that is 30 degree. In a horizontal, calculate the maximum height. Maximum height is nothing but here. What they have given is cricket ball, that is you have obtained V naught, that is V naught is equal to 28 meter per second, and theta is equal to 30 degree. And first one is you have to calculate the maximum height. Maximum height formula is, you know, that V naught sine theta by 2g whole square. Substituting the values, V naught you know, sine theta you know, and g is 9 point and g is 9.8. Substituting this value and calculating, you will get around 10 meter. This is for A. Next one is B. What you need to find out in B is time taken by a ball to return to the same level. That is time of flight. B is equal to time of flight is given by 2 V naught 2 V naught sine theta by g. You know the value of V naught, that is 28, and theta 30 degree, and g after finding out you will get 2.85 second. Okay. Next one is coming up to the third option. The distance from the thrower to the point where the ball returned to the same level. Return to the same level is range. R is given by R is equal to V naught square sine 2 theta by g. Substituting the values V naught and theta and g value, you will get around 69.2 meter. It is the answer. It is the answer for the first question. And coming up to the next second one, that is a driver of three-wheeler is moving with a speed of 36 km per hour. Seeing child standing in the middle of the road, bring his vehicle to rest in 4 seconds, just in time to save the child. What is the average retarding force on the vehicle? Here it is stopping potential retardation. Here what they have given is initial driver is moving with a speed of 36. Initially it is moving at 36, and he will bring down the velocity. So final velocity is near becomes 0 in the time 4 second. It was moving at 36 kilometer, and it comes the final velocity comes to 0 in the 4 second. So that the initial velocity V naught can be written as 36 kilometer per hour. If I convert into meter per second, that is 36 into 5 by 18, that will becomes 10 meter per second. And V, that is final velocity, is 0 because it is a stopping potential, and time is given t is equal to 4 second. Now we need to find the retardation, that is A is equal to V minus V naught by T. We know that from the kinematic equation, we know that final velocity is 0 minus initial velocity is 10 meter per second. 10 divided by time is 4. That is equal to minus 2.5 meter per second square. Okay. Now total mass. What you need to find out is, for second to say that what is the average retarding force, you need to find out the force. Okay. Wait. Here they are. They have given mass. Mass of the two wheeler is 400 kg and driver is 65 kg. Okay. So they have given the mass. Total mass. Total mass, that is equal to mass of the driver plus mass of the vehicle. That will becomes 65 plus 400 is equal to 465 kg. Now what we need to find out is force, that is average retarding force. We know that F is equal to ma. F is equal to ma. we know the value of m, that is 465 into, and acceleration is minus 2.5. I can take it as magnitude and it is 2.5. Calculating this, I will get around 1.2 into 10 to the power 3 Newton. Okay. Next one. Next one is a pump. A pump on the ground floor of a building pumps water to fill the tank volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and efficiency of the pump is 30%, how the electric power is consumed by the pump? Given is G is 9.8 and density is 10. So G is given, density of water is given, and the volume of the tank is given, and time is given 15 minutes, and the height is given, that is 40 meter, and the efficiency of the pump which is given as 30%. Okay, let's calculate. They have given V. Let us consider V is 30 meter cube, T is 15 meter, 15 meters, and next one is H is 40 meter, and N1 is 30%, and density of water is 1000 kg, and gravitation. Now, mass of the water pumped given by M is equal to V rho. Okay, that is V is nothing but volume. Volume is 30 into density of the water is 1000. I will get around 3 into 10 to the power 4 kg. Okay, next what you need to find out is output power, that is P is equal to mgh by T. M I know the value, G I know the value, and H is given by height. That height is nothing but 40 here, 40 meter above the 40 meter above, that is H is equal to 40 meter, and time is given here 15 minutes. 15 minutes can be converted into seconds, that is T is equal to 15 into 60. You will get around some value, or substitute 15 into 60 here only. After calculating this part, substituting and calculating, you will get around 13067 watt. So you get the power, output power. Now you have to find efficiency. Efficiency is nothing but N is equal to P naught by Pi, that is equal to power output by power input. Power output is 13067 divided by power input is 30%, that is 0.3. After calculating, you will get the answer. Now coming up to the last question of the numerical. Calculate the acceleration due to gravity at a point 64 kilometer above and 32 kilometer below the surface of the earth. What is the value of acceleration due to gravity on the earth? Given radius of the earth is 6400 kilometer, acceleration of the gravity is 9.8. So radius of the earth is given, 6400, and acceleration due to gravity is 9.8. Now substituting the value, we will get first one above the earth. Above the earth formula, we know that GH is equal to G into 1 minus 2H divided by RE. So you know the value of radius of the earth 6400. For this, H is given 64 kilometer. That can be calculated at 64 into 5 by 18. Okay, next one. Next, G is given, so you will find the value of G, that is otherwise you will mention 64 only. For height 64 only, you will get the value of 9.6 meter per second square. Okay, sorry, kilometer per second square. because we didn't converted this kilometer into meter, that's why it is a kilometer per second square. Next one is 2, that is GD, depth. GD is nothing but G into 1 minus depth D divided by RE. The value of depth is 32 kilometers. Radius, calculate this, you will get the value. And next one is, what is the value of acceleration due to on the gravity on the earth center is, it is at 0. Okay, hope you all understand. Thank you.